Pythagoras is sure that this number must be rational, but Hippasus says no, unfortunately it's not, and he has a proof, right? That shows that the number root 2 is not rational. So let's go through this proof together. And so what we're going to do is we're going to do a proof by contradiction. Right? In class, I told you guys that basically there's two ways to prove things. You can prove something directly or indirectly, and the idea is relatively simple. Suppose this is a road. Right, and here's my house on the road, and I'm right here. I know I live to the right. I can see it on the piece of paper, but I want to prove it. So one way to prove it is directly. So I'd say, turn to the right. I hit my house, hence my house is to the right. But I could also prove this indirectly, right? Assume it's not to the right. So then I go left. I never hit my house, so my assumption must have been wrong. It's to the right. That's an indirect proof, or proof by contradiction. Right? So we're going to prove root 2 is irrational. Right? We'll assume the opposite. We'll assume it's rational and see if we don't arrive at some contradiction. So we'll assume root 2 is rational. So we can express root 2 as a over b, where a and b are nice numbers, natural numbers, and they have nothing in common. Right? If they have something in common, we can cancel them off. So you can make the assumption that they have nothing in common. Right, so first we multiply both sides by b. If we multiply both sides by b, right, multiply this side by b and this side by b, of course b's will cancel on this side, and you get root 2 times b equals a. All right, which implies if you square both sides, if you square this side, and then you square this side, right, square root of 2 squared is 2, and you get b squared, and then down here you get a squared. Now, since the left side of the equation, so right here, is even, we know the right side must also be. Well, if you have a property over here, this is even, then a squared must also be even. Thus, a is an even number. Right, so notice this. If a squared is equal to an even, right, you have two choices for a. It's either even or odd. But notice, if you take an odd number and you square it, right, an odd times an odd is always a what? An odd. Right, so this, I know now that a must be even. So if you have a squared is even, a must be even. All right, so hence what we have is 2b squared equals an even squared, because we know a is even. That's an even then times an even. And the next statement says, which implies b must also be even. The idea of this is that, this 2 can take care of this even, but that means then b squared must also be even. Right? And if b squared is even, just like when a squared was even, then we know b is even too. Because an odd times an odd will give you an odd, so b must be even. Right. If a and b are both even, then they must have what number in common? Right. Even numbers always have a 2 in common. But a and b have nothing in common, so they cannot have this number in common. Right. This is called a contradiction. Right. The contradiction is we assume they have nothing in common, and then we show they have a 2 in common. Right, the two statements contradict each other, so we know that our assumption that root 2 is rational must have been wrong. Therefore, root 2 is a rational number. Right. So Pythagoras is, startling, perplexing. Tell no one of your discovery or it'll be the end of us. And then the story goes that poor Hippasus was later found drowned at sea. Some claim that it was murder, that the Pythagoreans did it in order to keep their cult alive. Others say that it was the irrational nature of this new number that drove Hippasus insane.